Hello guys, welcome on Tesla Eduventures. In this video, we are going to discuss the solutions of JEE Advanced 2024 physics part. So let us start from the question number 1, and this is the paper 1. So you can see that there is a dimensionless quantity that is constructed in terms of electronic charge E and permittivity of free space epsilon naught, Planck's constant h, and speed of light c. Okay, and we have to construct a dimensionless quantity that is written in terms of these four quantities, where n is a non-zero integer. Then we have to find out the value of alpha, beta, gamma and delta, where alpha, beta, gamma and delta are their powers. We know that hc by lambda is energy, and we also know that potential energy is dimensionally q square by 4 pi epsilon naught r. So let us see that this is q square is E square upon 4 pi epsilon naught r. I am cancelling out the dimensions, so I am cancelling the quantities according to their dimensions, because the dimensions of lambda and dimensions of r is same. So I can say that h in this is h c into 4 pi epsilon naught, and e to the power minus 2 is dimensionless, no dimensions. And we know that 4 pi also do not have any dimensions, so we can say that h c epsilon naught e to the power minus 2 has no dimensions, which can we can also easily predict that the unit of the power of h c and epsilon naught would be same. So power of h c and epsilon naught should be same, so beta, gamma and delta should be same, and that power should be equal to minus half of power of e. So according to that, we can see that the correct option will be option A. Now we move on the next question. In this question, you can see that there is an infinitely long wire that is located on the z-axis. So let us first of all draw the situation. So there is a infinitely long wire which is located at z-axis, along z-axis. It carries a current I along the positive z direction, and it produces a magnetic field B in the region around it. So we have to find out the line integral B dot dl along a straight line which is starting from this point and ending to this point. So if we see that these both points have same y coordinates, so this point will be obviously lying, these 2 points will be lying in xy plane, and this is x and this is y. So this would be a straight line. The line connecting these 2 points will be a straight line. This is this straight line, and this point will be root 3 minus root 3 a comma a, and this point will be a comma a. So you can see that this angle will be equal to 45 degree, and this angle will be equal to 30 degree, because this is y is a and x is root 3a, so 1 by root 3 is tan inverse 1 by root 3 is 30 degree. So this is the wire. Now let us again draw this line for better understanding. So this is the line, and let us draw the wire. This is the wire, and this is y-axis. So if we find out the magnetic field at this point, which is having some coordinate x comma y, so this is r, and r will be equal to under root of x square plus y square. R will be under root of x square plus y square, and we can say that the current is coming out of the paper, so out of this plane, so magnetic field would be pointing like that. So if this angle is theta, so this angle would be 90 minus theta, and this angle, or we can also apply the limit of this angle. So this is theta, this is also theta, and this is 90 minus theta. So this is B. So if we write down B in vector form, then in vector form B would be equal to minus B sine theta I cap plus b cos theta j cap. This is b in vector form, and the value of b will be mu naught I by 2 pi r, because this wire is going from minus infinity to plus infinity, therefore its both angles would be 90-90. So this magnetic field will be mu naught I by 2 pi r. So b value of b is this. And now we have to find out the integral b dot dl. So let us assume a small vector dl. So dl vector will be along this line, and this line has constant y and constant z. So only x is varying in this line. So we can assume that dl vector is dx I cap. And when we will find out the integration of b dot dl, then obviously it would be integration of b is mu naught I by 2 pi r and sine theta, and limit would be dx. Okay, and this would be dx, and we have to find out the value of sine theta. So sine theta will be, this is a, and sine theta will be a by r. So it would be equal to integration mu naught I by 2 pi r. Now we can write down r as this, and we know that y is a, so r is under root x square plus a square. So this is r square, and in the numerator it would be a. So it would be integration dx also. It would be integration mu naught I a dx divided by 2 pi x square plus a square, and the limit of x would be from minus root 3 a to a. So this is minus root 3 a to a. Now we can see that mu naught I a is taken out, and 2 pi is also taken out, and the integration of dx upon a square plus x square, and the limit will be minus root 3a to a, minus root 3a to a. So integration of this term is tan inverse 1 by a, tan inverse x by a. So this would be mu naught I by 2 pi, and the limit was minus root 3a minus root 3a to a. So you can see that it would be tan inverse 1, and minus would be plus, so tan inverse root 3. So we know that tan inverse 1 is pi by 4, and tan inverse root 3 is pi by 6, 30 degree, in fact pi by 3. Okay, so this is 12, and this LCM would be 7 pi, and this would be mu naught I by 2 pi, cancelling out pi with pi, so it would be 7 mu naught I by 24. So the correct option would be 7 mu naught I by 24, which is option A. Now we move on the next question. In this question, you can see that there are two beads on a ring. So let us draw the ring. This is the ring, and there are two beads on this ring, and these two beads have same mass and same charge q. So this ring is kept on a horizontal frictionless non-conducting table, and this circular hoop is also non-conducting, and it does not have any friction. So one of this bead is being glued. Let us draw the bead. So let us draw this bead, this one, and this is glued, and the other bead is performing SHM about the equilibrium position. So we know obviously that the equilibrium position would be this one, because apart from this position, let us suppose that if we consider the equilibrium position, this one, so if we see that the force would be acting like that, so there will be a component of the force in the tangential direction like that, and or we can say that there will be a component of this force along this direction and along this direction. So bead will be sliding along this ring, because this force would have a component which is not in the direction of the radial direction of this bead. So we know that this force, the equilibrium position would be the position where this force would be in the radial direction. So this position would be like that. Here it would be the equilibrium position, because in this position the electrostatic repulsion force would be acting like that, and the normal reaction of the bead would be balancing this force. So if we displace this bead from this position, so let us draw the new position. So if we displace this bead from this position by a small displacement theta, so this is the new position, so force would be acting like that, F, and this displacement is very small, so we know that this angle would be 2 theta. So let us solve this question by using the angular SHM. So this angle is also theta, so this component is F sine theta. So F sine theta would be the force which would be producing the torque about center of the ring. So the torque of F sine theta would be F sine theta multiplied by R. This is the radius of the ring. Okay, and the value of F can be easily calculated. So because F is k q square by R. In fact, this distance, this is 2R, and if we have displaced by a very small angle, then this length would also be approximately 2R. Otherwise this length would be 2R cos theta. You can find out by using sine law. So this would be 2R cos theta, but for small angles cos theta is 1, so we can say that this length would be 2R, so this would be 4R square. So the torque would be equal to k q square by 4R square, and for small angles it would be theta and it would be R. So I can cancel out this R, and this would be like that, and torque will be equal to I alpha. Now we know that the moment of inertia of this ring about the center would be mr square, and alpha will be omega square theta. But you should be carefully observing this term theta, because this angle, we are writing the torque about center of mass. In fact, we are writing the torque about the ring center of this bigger ring hoop. So about this point, this angle is 2 theta. So displacement angle will be 2 theta. Okay, and we can also write down k as 1 upon 4 pi epsilon naught. So cancelling out theta with theta. So this is q square upon 16 pi epsilon naught r cube m divided by 2. So it would be 32. So this is omega square, and we have to find out the omega square. So the correct answer would be option B. Now we move on the next question. In this question, you can see that there is a block of mass 5 kg, and it is moving on the x-axis, and it is subjected to a force of F is equal to minus 20x plus 10. Now this value of x is in meters, and at t is equal to 0, this block is at rest at position x is equal to 1. So we have to find out the position and the momentum of the block at t is equal to pi by 4. So F is equal to minus 20x plus 10. So if we write down F as taking minus 20 common, so it would be x minus half. Okay, so you can easily see that this is our general form of SHM, and k is 20, this term is k, and k is equal to m omega square, So omega will be equal to 20 by root of 20 by 5, which is 2, and mean position will be equal to x is equal to half. This is the mean position. Okay, and we can also write down the equation of SHM, and it is also given that it is the mean position is x is equal to half, and it is at rest at position x is equal to 1 initially at t is equal to 0. So we know that this is positive extreme position of SHM, and at this position the phase is pi by 2. So we can write down that the equation of SHM would be x minus half, and the amplitude would be this one. This is half, this is, and sine of omega is 2, and t plus initial phase is pi by 2. So this is the equation of SHM, and x will be equal to 1 by 2 plus 1 by 2 sine 2t plus pi by 2. Okay, this is x. So at t is equal to pi by 4, at t is equal to pi by 4, you can see that if we keep pi by 4 here, it would be pi by 2 plus pi by 2 pi, and sine pi is 0. So position is 0.5, and if we differentiate this equation to find out the velocity, so it would be 1 cos 2t plus pi by 2. Okay, and at t is equal to pi by 4, cos pi would be equal to, v would be equal to 1 cos pi, and cos pi is minus 1, so v would be equal to minus 1. So the momentum would be mv will be equal to minus 5. So the correct answer of this question would be C. Now we move on the next question. In this question, you can see that there is a particle of mass m which is moving in a circular orbit under the influence of a central force F, which is equal to minus kr. And the corresponding potential energy of that particle is kr square by 2, where k is a positive constant and r is the radial distance from the origin. Now, according to the Bohr's quantization rule, the angular momentum of the particle is given by L is equal to nh, we know that, and in fact this is nh hash. So h hash is h by 2 pi, and v is the speed of the particle in the circular orbit, and E is the total energy of the particle. So we have to find out that which of the following option is correct. So this is I think quite an easy question. So it would be, we know that this minus sign represents that this force is attractive, so we just have to ignore this minus sign. So kr would be equal to mv square by r. So kr square is equal to mv square. This is the first equation, and mvr is equal to nh hash. Okay, so we can substitute the value of v in this equation, or we can find out the value of v from this one. So it is v is equal to nh hash by mr. So we can substitute this value of v in the first equation. So if we substitute it, so kr square will be equal to, this is m v square. So v square will be equal to n square h hash square divided by m square r square. So r to the power 4 will be equal to this is n square h hash square divided by k m, and r square will be equal to n h hash divided by m k. So first option is correct, and v square we have to find out. So if we substitute the value of r here, so it would be v square will be equal to n square h hash square by m square, and r square is n h hash upon this is mk. So you can see that cancelling n with n, h hash with h hash, so the correct answer will be B option also. Now C is the angular momentum. So we know that angular momentum is itself mvr, so mvr is nh hash. So nh hash, let us see that L upon mr square. So L is nh hash divided by mr square. So m and r square is nh hash divided by under root mk. So cancelling out nh hash, so it would be equal to under root of k by m. So C is also correct, and D is the energy. So the energy would be equal to the kinetic and potential, and we know that this is Ke plus Pe. Now Ke, kinetic energy, is half mv square, so half mv square will be kr square by 2. So this is kr square by 2, and potential will be kr square by 2. So this is kr square, and the value of r square is this one. So you can see if we substitute the value here, D would be incorrect. So the only correct answers are A, B and C. Now we move on the next question. In this question, you can see that there are two uniform strings of mass per unit length, mu and 4 mu respectively. So one string is lighter and the second one is heavier, and the length of these strings are L and 2L. Now they are joined and they are tied to the two ends P and Q as shown, and these strings are under the uniform tension T. So we define the frequency nu naught as 1 by 2L under root T by mu. Which of the following option is our correct? So if there is node at point O, so let us assume that there are n number of loops in this string n, and there are m number of loops in this string. M. Okay. So we can say that frequency would be same because wave is same, which is traveling in both the strings. So the frequency in the first string will be n by 2L under root T by mu, and that would be equal to m by 2L under root T by 4 mu. So you can see that n will be equal to, from this we can say that n will be equal to m by 2. In fact, this length is also 2L, so it would be 4. So this is m by 4. Okay, so n and m. If we know that m is 4 times, so if n is 1, m will be 4. So in the this is fundamental frequency. So in the fundamental case, nu 1, which is the fundamental frequency, will be equal to 1 by 2L under root T by mu. So this is nu naught. So A option says that with node at point A, the minimum frequency of the vibration of this composite string is nu naught. Now with antinode at O, the minimum frequency of vibration is this. So we know that if there is antinode at this point, then there would be a diagram like that. Let us draw like that. So in this case, we know that the frequency is equal to odd number like 3 by 4L, 5 by 4L. So this is odd number under root T by mu. So for second case, if there is antinode, so let us assume that n and m are odd numbers. So n by 4L under root T by mu will be equal to m by, this is 4 into 2, 8L under root T by 4 mu. This is 4 mu. So you can see that n will be equal to m by 4 again. And for no set of values of n and m, keeping in mind that n and m are odd numbers, so this ratio would be 4. So B is incorrect because it says that the frequency of vibration of the composite string will be 2 nu naught, and also option D is incorrect because option D is correct because it says that no vibrational mode with an antinode at O is possible for the composite string. This is also correct. And when composite string vibrates at the minimum frequency with node at A, it has 6 nodes including the end nodes. So you can see that if we see that in the basic mode of vibration, there are if there is one loop, then the number of nodes are 1 plus 1 2. If there are two loops, then number of nodes are 3. So if you can see that there are in the fundamental vibrational mode, there are one loop in the lighter string and there are 4 loops in the heavier string. So total number of loops would be 5 and the total nodes would be 6. So C is correct. So the correct answers are A, C and D. Now we move on the next question. In this question, you can see that there is a glass beaker which has solid plano-convex base. The refractive index of this glass beaker is 1.6 and the radius of curvature is 9 centimeter. This plane surface of this beaker acts as a mirror, and this beaker is being filled with a liquid of refractive index N. Okay, now we have placed an object at a height of h from this beaker, and the final image of this object is formed at the object itself. So we have to find out the value of h for n. We have to find out the correct combination of n and h, so that the image is formed at object itself. We know that first of all there would be a refraction of light which is entering from air to this liquid, and we know that directly we can apply the formula y is equal to x upon mu relative. As we know, by applying this formula we can shift the image 1 from this surface by a distance of nh. We already have used this technique in the previous videos of geometrical optics. You can refer to the playlist. So this is nh, and obviously this is the image for the refraction on this convex surface. Now obviously you can see that the ray diagram would be seen like that. The ray would be appearing to be coming from I1, and after refraction from this surface, ray should go parallel to this axis so that it can be reflected back on its path, and the final image is formed at the object itself. So for this purpose we can see that the final image of the refraction on this convex surface would be at infinity. So we can use the formula mu2 by v minus mu1 by u is equal to this is u is equal to mu2 minus mu1 by r. So mu2 is 1.6 and v is infinity, and mu1 is this liquid and n, and u will be equal to minus of nh, this is nh, and mu2 minus mu1. So mu2 is 1.6 minus mu1 is n divided by r, where r is the radius of curvature, it is 9. So you can see that h will be equal to 9 upon 1.6 minus n. So you can see that we can check this one. So this is 9, we can check option 1. So if n is 1.42, so this is 1.6 minus 1.42, so this is 0.18, so this is 9 upon 0.18. So h will be equal to 50 centimeters. So A is correct, and similarly B would be correct. So the correct answers would be A and B. Now we move on the next question. In this question, you can see that the specific heat capacity of a substance is temperature dependent, and it is given by the formula C is equal to kT, where K is suitable constant, which positive constant, and T is the absolute temperature. Now we have to find out the heat required to raise the temperature of 1 kg of any substance from minus 73 degrees Celsius, which is 200 Kelvin, to 27 degrees Celsius, which is 300 Kelvin. So we know that dq is equal to nc dt. Okay, and the mass, in fact, this is mc dt, and the mass is 1 kg, so dq will be equal to 1 into c. C is ct and this is dt. Now we have to integrate this term, and this would be ct square by 2, and c is k, in fact kt square by 2, and the limit of t would be from 200 to 300. So q will be equal to k by 2, and this is 90,000 minus 40,000. So k by 2, this would be 50,000, so n will be equal to 25,000. So the correct answer is 25,000. Now we move on the next question. In this question, you can see that this is a disk of mass m and radius r. It is free to rotate about this vertical axis, and a battery operated motor of negligible mass is being fixed to this disk at a point on its circumference. I'll show you the upper view of this diagram, and another disk of same mass and radius r by 2 is being fixed to that motor by a thin shaft, and initially both these disks are at rest. So this motor is switched on, and it is observed that the smaller disk rotates with the uniform angular velocity of omega. So we have to find out the speed with which the larger angular disk will rotate. So you can see that I'll show you the diagram, cross section view. So let us see that this is the bigger disk, and there is a small shaft of motor. Motor shaft is a small rod that rotates the motor, and there is a bigger disk, this disk, which is at the center of this shaft. So you can imagine that there is a thin hole in the center of this disk, and this shaft is crossing this hole, and also this shaft is touching this disk. So in this case, you can see that this disk would be rotating due to the friction of this shaft, and also this disk would be rotating due to the friction of this shaft. So you can see that if this shaft is rotating like that, like let us suppose that it is rotating anti-clockwise, so this blue disk, smaller disk, will be rotating anti-clockwise, and the bigger disk will be rotating clockwise. And at this point, obviously the net torque of the friction will be 0 on the both disks, both of them combinedly known as system. So we can conserve the angular momentum of these two disks about this point. So this point is the center of smaller disk, so its angular momentum is 1 by 2 I omega. I am writing I omega, so 1 by 2 m r square by 4 into omega, and at this point the moment of inertia of the bigger disk would be 3 by 2 m, which is m, and r square into omega dash. So you can see that omega dash will be equal to omega by 12. So n will be equal to 12. Now we move on the next question. In this question, you can see that there is a point source of light S that emits unpolarized light uniformly in all the directions. At 2 points A and B, the ratio of the intensity of light is IA upon IB, and this is R, and at some point this ratio is 2. Now we have set up a set of two Polaroids which have 45-degree angle between their pass axis, and that setup is just placed before point B. So we have to find out the new value of R. So let us see that if this is point A, then intensity at point A is IA, and if this is point B, then intensity at point B is IB. So initially it is given that IA upon IB is equal to 2. Okay, and when we have placed set of two Polaroids, so let us see that, let us imagine that there is no gap or negligible gap between these two, and these are just placed at this point. So the intensity which would be incident on the first Polaroid would be IB, and after passing through, this is unpolarized light, so we know that after passing through this Polaroid, the principal axis would be like that, and intensity would be IB by 2. We know that average intensity of unpolarized light after passing through a polarizer is half. Now the other Polaroid is having an axis which is at an angle of 45 degree, so the intensity at behind this second Polaroid would be IB nu. So IB nu would be IB by 2 cos square 45. So this is IB by 2, and cos square 45 is 1 by 2. So this is IB by 4. This is IB nu. Okay. So we have to find out the new ratio of IB and IA. So R nu will be equal to IB, IA by IB. So IA is IA and IB is IB by 4. And this is the old value of R, which is 2. So the new value of R would be 8. So the correct answer is 8. Now we move on the next question. In this question, you can see that there are two point objects. One is source and one is observer, and they are moving towards each other with a velocity v, uniform velocity v. The original frequency of the sound is 240 Hertz, which is emitted by the source, and that sound is observed by the observer, and the observer observes a sound of frequency of 288 Hertz. However, when they are moving in the opposite direction with the same speed, we have to find out the new frequency of sound that would be observed by the observer. So in the first case, we know that f dash would be equal to v plus vo upon v minus vs into f, and f dash is 288, and v plus sound velocity is equal to let's suppose velocity of sound is v naught, yeah, or vs, and observer velocity is v, and source velocity is also v. So this is 240. So this is first equation, and vs minus v upon vs plus v from this equation would be equal to 240 by 288. Now in the second case, we have to find out the new frequency f double dash, and in the second case they are moving away, so this would be vs minus v upon vs plus v, and the original frequency is 240. So the value of vs minus v upon vs plus v is 240 by 288. So f double dash is 240 square by 288. So this the value of n would be equal to 200. So the correct answer is 200. Now we move on the next question. In this question, you can see that there are two tanks and one tank has a small hole at the bottom, and these tanks are kept on the top of a building, and from one tank water is leaking out from this hole, and initial height of the water in this tank is h. The height of the building is h, but in the other tank there is a pipe attached to the hole, and this pipe is taking water to the bottom of the building, and here it is getting leaked out. So we have to find out the ratio of the time taken by the water to time taken in emptying the container. So we know we have already derived the formula of time. So time is equal to capital A by small a, and under root of, this is the ratio of area, under root of 2h by g, and the T2 in the second case would be equal to capital A by small a under root of. Now in the second case you can easily see we have derived this formula by integration. You can refer. In fact, I have not created the videos of this fluids, so let us derive this formula, and no worries. So let us see that in the first case, let us see that water is at a height of y from the bottom at any instant of time, and the area of container is A and area of cross section is small a. So at this instant of time, the liquid coming out from this would be having a velocity of under root 2gy. This can be used, this can be find out by using the Bernoulli theorem. Okay, so this is under root 2gy, so we can use the continuity equation, and continuity equation says that a1 v1 is equal to a2 v2. So a into v, where a is the cross section of this hole, is equal to capital A into dy by dt, where dy by dt is the rate at which this liquid is going down. So if this liquid is going down, then dy by dt would be negative. So there would be a negative sign, and v is equal to under root 2gy. So this is minus a by a into under root of 2gy is equal to dy by dt, and this is dy upon under root of 2gy is equal to a by a, in fact small a by capital A into dt with a negative sign, and limit would be 0 to t. Now we use this we know that initial height was h and finally it is 0, so limit would be from h to 0, but by using that negative sign I have changed the limit, so it would be from 0 to h. So integration would be under root of 2h by g, and this is a by a t1. So t1 will be equal to a by a under root of 2h by g. And in the similar way, if we integrate for different limits, because in this case the water level is water is going down to the bottom of the building by this pipe, so we will be getting, let us derive this formula from this stage. So minus of a by a into integration of 2g. Now this height would be equal to h. In fact, if this is y at any time, this is y and this is h, so velocity will be y plus h, and it would be equal to t2. Now the limit would be, we have to find out the time taken by the water to come out of the container. So limit of this y would be from 0 to h. We are using that negative sign. So this is by using this negative sign, this is plus. So t2 will be equal to under root of a by a under root of 2g, and in fact this g would be in the we have already integrated, so it would be in denominator. So we are writing down the limit. So by using the limit h, so it would be h plus h and minus under root 2g, and if we substitute the limit 0, so it would be capital H. So T1 by T2 is equal to under root of h upon under root h plus h minus under root h. Okay, so you can see that this is 1 upon under root of h by h plus 1 minus under root of h by h. So this is 1 upon h by h is 16 by 9. So this is under root of 16 by 9 plus 1 minus under root of 16 by 9. So this is 25, 1 upon under root of 25 by 9. 25 by 9 is 5 by 3 minus this is 4 by 3. So this is 3. So the correct answer of this question is 3. Now we move on the next question. In this question, you can see that there is a thin rod of length L, and this rod is connected with a rope of length L. There is a sharp impulse which is given to this rod. This complete system is in horizontal plane and there is no friction anywhere. There is a sharp impulse which is given to this rod at a distance of x from the center of the rod, and due to that impulse these two starts to rotate, and these rod and string are rotating aligned with each other in a straight line. Okay, so we have to find out the value of x and we have to compare that x with L by N. So let us start this problem. Let us see that first of all the velocity of center of mass of this rod, let us draw the rod. The velocity of center of mass of the rod Vc will be equal to impulse by mass V by M. And let us find out the angular momentum of the rod about O. So angular momentum of the rod about O will be equal to angular impulse, and angular impulse will be equal to P into this distance. This is 3L by 2 plus x, and the moment of inertia of this rod about O will be 7 by 3 ml square. You can calculate 7 by 3 ml square omega. So omega will be equal to 3p by 7 ml square into this L is capital L, so let us write it down as capital L. So omega will be equal to 3p by 7 ml square into 3L by 2 plus x. This is omega. Okay, and if we see that the velocity of this point Vb, so Vb will be equal to L omega. So L omega, so Vb will be equal to 3p by 7 ml into 3L by 2 plus x. And by this figure you can also see that if this rod is rotating like that, so the velocity of this point VCOM will be this one, and velocity of this point will be VCOM minus L by 2 omega. So VCOM is P by M, so P by M minus L by 2 omega, this is omega, is equal to Vb. Vb is L omega. So P by M is equal to 3 by 2 L omega. Omega is this one, 3p by 7 ml square into 3L by 2 plus x. Okay, so cancelling L with L. So this is 9 by 14, cancelling P by M with P by M. So 1 is equal to 9 by 14 L. This is 9 by 14 L into 3L by 2 plus x. 3L by 2 plus x. So 3L by 2 plus X is equal to 14L by 9. X is equal to 14L by 9 minus 3L by 2. So X is equal to, taking LCM, this is 28L and this is 27L. So X is equal to L by 18. So N will be equal to 18. So the correct answer of this question is 18. Now we move on the next question. In this question, you can see that 1 mole of an ideal monoatomic gas undergoes this cyclic process JKLMJ, and a PT diagram of this process is shown. So we have to choose the correct options. Let us analyze option P, work done. So let us see that or we can also check the other options. We can also check Q option and S option. So because work done checking would be a lengthier process, although it can be done, but let me check the option Q first. So change in internal energy of the gas in J2K. So in J2K, the temperature changes to T0 and the delta U will be equal to NCV into delta T. N is 1 and monoatomic gas has CV as 3 by 2 R and delta T is 2T. So delta U will be equal to 3R T0. So the correct matching for option Q is 3. So the only possible options are A and B. Now let us match the option S. The change in internal energy of the gas in process MJ. So now in MJ, I am not solving the complete question. Okay, you can solve this question. This is very easy one, and you can find out the work done also. So in the process of MJ, M to J, we have to find out the change in internal energy. So change in internal energy of the gas in MJ is 0, obviously, because temperature is constant. So the correct matching would be S with 2. So the correct answer would be B. Now let's move on the next question. In this question, you can see that there are 4 thin square metal sheets S1, S2, S3 and S4, each having a side A. Okay, and these are kept parallel to each other with the distance between each of them is D. And the value of C naught is epsilon naught A square by D, where epsilon naught is the permittivity of free space. So the capacitance between S1 and S2 with S2 and S3 not connected. In fact, the capacitance between S1 and S4 with S2 and S3 not connected. Okay, so you can see we can draw the diagram. So this is S1, it is making capacitance with S2, S2 is making capacitance with S3, and S3 is making capacitance with S4, and we have to find out the capacitance between S1 and S4. So this is point A and this is point B. Okay, and S2 and S3 are not connected. So you can see that this equivalent will be equal to C by 3 because all 3 are in parallel. So this is C naught by 3. So the correct matching for option P is 3. So this is not possible. Now let us check the option S. So for S option, this would be easier. The capacitance between S1 and S2 with S3 short circuited to S1 and S2 short circuited to S4. Now you can see that, let us draw the diagram again. This is S1, S2, S2, S3, S3, S4. And we have to find out the capacitance between S1 and S2 and with S3 short circuited to S2. In fact, S3 short circuited to S1. So these two are connected. Point A is this, point B is this, and S2 is short circuited to S4. So S2 is short circuited to S4. So you can see that these three are in parallel. So C equivalent will be 3C naught. So the correct matching of S is 1. So the correct answer is C. Now we move on the next question. In this question, you can see that there is a light ray which is entering a sphere like that. Let's suppose the angle of incidence is I, and it is given that the refractive index of the sphere is n and angle of refraction is phi naught. It gets reflected from this end, so this would be phi naught, and again it gets refracted from this end, so this will be also phi naught, and this will be I. So the total deviation alpha, we have to find out the value of alpha. So we know that in this case, for first refraction, the deviation will be I minus phi naught. You can see that this is the deviation. So del will be I minus phi naught plus, in the reflection, del would be 180 minus 2 phi naught, and in this refraction again, the del will be in the same sense I minus phi naught. So the total del is alpha. So alpha will be equal to this is 180 plus 2i and minus 4 phi naught. Okay, and we have to match the correct options. First of all, we can see, and another we can also use the Snell's law, that 1 sin I will be equal to n sin phi naught. So for option P, alpha is 180. So let us check P. So if alpha is 180, 180 will be equal to 180 plus 2i minus 4 phi naught. So I will be equal to 2 phi naught. So this is 2 sin phi naught cos phi naught is equal to, n is 2 sin phi naught, cancelling sin phi naught, cos phi naught is equal to 1, and phi naught will be equal to 0 degree. So if phi is 0, so value of theta naught, where theta naught was the angle of incidence, so angle of incidence I will be 0 degree. So the correct matching for option P will be A, will be 5th. So the correct options can be A and B. Now let us calculate, check the Q option. So if n is root 3, so if it is root 3, you can see that cos phi naught will be equal to root 3 by 2. So phi naught will be equal to 30 degree. So if this phi naught is 30, I will be 60 degree. So the correct matching for the Q option will be option 2, because these are also valid for 0 degree, because if I is 0, phi naught is 0, then for any value of n, I would be 0. So the correct answer of this question would be option A. Now we move on the next question. In this question, you can see that there is a circuit in which there are two switches which are initially open, and a capacitor, inductor, resistor and an ideal battery are connected. Initially this key K1 is closed, and immediately after closing this key K1, the current through this resistor was I1. So we know that as soon as we will close this key, there is no use of capacitor, but there would be a RL circuit, and at t is equal to 0, the current in the RL circuit is 0, so I1 will be 0. So the correct matching of P is 1. And if we check that after long time the current is I2, so after long time inductor behaves like short circuited, so current will be 20 by 5, which is 4 ampere. So the correct matching for Q is 3. And let us check S option. In S option we have to find out the value of V0. So the value of V0 will be now V0 is the maximum voltage on the capacitor, so you can see that the maximum energy stored in the inductor is half L I0 square. So this is half L is 25 into 10 raised to power minus 3, and I0 square is 16, and this will be equal to half CV square. C is 10 into 10 raised to power minus 6 into V square. So cancelling half with half, 25 into 16 will be equal to 400, and this is 40,000, and that is V square, so V will be equal to 200. So the correct matching for S will be 5. So the correct answer is A. So this was the first paper of JEE Advanced, and if I analyze this paper, I find it very easy as compared to the JEE Advanced 2023. So I do not find any difficult question in this paper. So I don't know why some people are saying that physics was lengthy or physics was tough. Okay, and in fact most of the students which have prepared for year long for JEE Advanced, they would find this paper easy, and there is no tough calculation also in this paper, and these things are already being taught in the classroom, so I do not find anything difficult or anything new concept in this test. So I'll be now uploading the paper 2 solutions also. So thank you.